So remember that we looked at sine and we looked at cosine. And we said that those are our two most common graphs, which is why we spent like quite a few more days on that than we are going to do the rest of our graphs. But I still want you to at least kind of see what these graphs look like. So today we are looking at tangent. Now we're going to start tangent the same way that we did sine and cosine. We're going to make a table first to kind of give us an idea of what the parent function looks like, and then we will look at just a couple of transformations. So again, remember that our inputs are going to be thetas or x's, okay? So I have tangent of theta or tangent of x. Either one is fine. So we're going to start at 0, just like we did with our other ones. And remind me, what ratio is tangent? Yep, opposite over adjacent. Or remember that we also had it as y over x. Yes? But on our unit circle, what was equal to y? Sine. And what was equal to x? Cosine. So tangent is sine over cosine. Which means that, remember that at pi over 4, those two things are equal. And so we're going to get nice numbers like 1 at pi over 4. So I'm not going to put in all of the values from our unit circle, just because we would have to do a decimal approximation for all of those. And at the end of the day, those aren't going to be our key points. Okay. So now let's evaluate. So what is sine at 0? Think about our sine graph. What is sine at 0? It is 0. What is cosine at 0? 1. So what ratio do we get? 0 divided by 1, which is also 0. Okay. Now, at pi over 4, right, we said that both sine and cosine are square root of 2 over 2. So if I divide those, what are we going to get? Just 1. So that's nice. Now, at pi over 2, what is sine? It is a what? For our sine graph. Might be helpful to either pull out your unit circle or your handout that had your sine and cosine values on it. So you need to know these. It's 1. And what is cosine at pi over 2? 0. So I get 1 over 0. What is that? It's not 0. It's undefined because our 0 is in the denominator. What about at 3 pi over 4? Both of them are still going to be square root of 2 over 2. But now that we're in our second quadrant, what happens? Yeah, cosine is negative, which means that tangent is going to be negative, so we get negative 1. At pi, sine is 0 again, and cosine is negative 1, so we're still going to get 0. At 5 pi over 4, which is our third quadrant, both sine and cosine are negative, so it'll now be a positive 1. At 3 pi over 4, we're negative 1 divided by 0, which is also undefined. At 7 pi over 4, now sine is negative, and then back to 2 pi, we're at 0. We're all okay with where we're getting those values from. We're using our graph some of these. So I have label. Let's go by pi over 4. Now, what happens when I have a value that is undefined on my graph? Correct. So we have a break in our graph of some sort. What have we looked at on our graphs where there's a break in that graph? There was holes, and there was also what? What's the other one? Asymptotes. So your tangent graph has asymptotes. Specifically at pi over 2 and at 3 pi over 2. And remember that our asymptotes are kind of like, we said, like black holes, right? It's going to suck our graph closer and closer to it. So we end up with something that looks slightly like a cubic graph. It's just kind of like squashed to be in between two numbers. Yes? Now, looking at that graph, so from pi over 2 to 3 pi over 2, okay, we have like our full graph. You notice that? Then we get the full, nice, pretty curve. Yes? At 0, if we start at 0, okay, notice that it cuts it off halfway. Okay? And we want to look at the full graph or the full curve like all together. So we could start our period at pi over 2 and go to 3 pi over 2. However, generally we like to be around 0. We like to include 0. So how might I get the other half of my graph from 0 to pi over 2? Would you like me to rephrase the question? We're missing half of our graph. Yes? So how could I add that half of the graph in? I could shift it over, or right now I'm starting at 0, right? What could I start at instead? Negative something, right? So like I'm just going to draw a part of my graph on the negative side, which is okay. So this graph is going to be a little bit different in the fact that we are not going to start it at 0 most of the time. Now remember that my graph is going to repeat itself over and over and over again, okay? So what happens after negative pi over 2 is the same thing that happens after pi over 2. So here it's going to be negative 1, and it's going to continue down forever. So when we're graphing our graph, okay, we want to center it around 0, which means that we need to include negative pi over 2 to pi over 2. Now, what do we notice about how often does this repeat itself? Yes, sorry. How long does it take it to repeat one cycle of values? For what? Okay. What did I label my units as, though? By pi over 4. So if I have 4 of those, how many pi's do we have? 1, right? Because I would have 4 pi over 4. Yes? So do we notice that it takes pi to repeat itself instead of 2 pi, like our sine and cosine? Yes? And what's the length that it takes to repeat itself called? The period. So the period of our tangent graph is pi instead of 2 pi. Yes? Okay. Also notice that our domain, okay, is it going to be all real numbers this time? No. We're not allowed to include basically in pi over 2. Okay, so just stuff that's in being like some number, right? Like we can't include, okay, those things. So it cannot equal that. But also notice for our range this time, it's going to be all real numbers. Because it goes on forever up and down. Yes? So we're not going to have a maximum or a minimum. Are we all okay with that? So then let's go ahead and label our key points. So notice that we're going to start at an asymptote, which means we also have to end at an asymptote. Halfway in between those two things is our 0. And then, like I said, we can't call these other 2 points our maxes and our mins, because it's not actually a max or a min, but those are still nice numbers to look at. So we're just going to see that's where y equals -1 and y equals 1. Okay? And I'm also going to label these x values, okay, because we have shifted it over. So we're starting at -pi over 2. Our next value is at pi over 4, then 0, then pi over 4, then pi over 2. What questions do we have on that? Now, we're not going to do a ton of transformations with this, but we will look at kind of period and a value, so like stretching it, like what that does to it, okay? So people still writing, so wait. Alright. So looking at this next one, let's make it a little bit bigger. What do we have there? Is it just our normal tangent graph? Is there something else in there? Yes, what is it? I have a 1/2. In what place or what variable is that 1/2 acting as? The p-value, yeah. So that's still going to affect our period, okay? The only difference this time is that our normal period we said is what? Pi. So instead of being 2 pi over b, it's going to be pi over b. So in this case, it's going to be pi over 1/2, which is also pi times 2, or 2. So notice that we don't have anything else going on, so that's not going to change anything else. Okay? Now, the thing that's a little bit different is normally we start our graph at 0 and we go to pi. Yes? Or in this case, we would go pi because it's tangent. However, with tangent, because I'm not starting at pi, we have to think about it a little bit differently. So with our key points, we're still gonna start and end at an asymptote. And 0 still has to be halfway in between. So if 0 has to be halfway in between, and the full distance has to be 2 pi, then how much has to be on both sides? Pi. So this time, instead of starting at pi over 2, we're going to start at negative pi and end at positive pi. Also, remember that your like 1 values, okay, are in between, exactly halfway in between my asymptotes and my 0. So now this is at negative pi over 2, and my second one is at pi over 2. And remember, these are the x values. Do y'all see where I got those numbers from? Yes? Okay. Because then we're just going to graph them. So I'm just going to label. We can go, let's go by pi's over 2 this time. Which means that this is negative pi, this is pi. I'm at 0, we're at negative 1, and 1. And I would have 1 full graph. What questions do we have there? For our last one, we're just going to look at what would happen if there's an a value up front. So remind me, what does the a value do to a graph? It does. So remember that amplitude is the max minus the min, right? But does tangent have a max and a min? No, so we can't technically call it amplitude this time. But in general, with all of our graphs, what does the a value do? Yeah, so it stretches it, or if it's a smaller number, right, it would shrink it. So it's going to change that y value. And remember that we looked at these two y values, so negative 1 and 1 are kind of like our nice y values, okay? And so those are the ones that when we look at a stretch, kind of like our max and our min of our sine and cosine, those are the ones that we're going to move. Because 1 is easy. If I multiply it by 2, it becomes 2. I multiply it by a fourth, it becomes a fourth. So those are going to be the two values that are easily affected by your amplitude. Or sorry, by your a value. It's not technically amplitude for tangent. So what do we have on this next one? What's our a value? Negative 3. So it means that it's been stretched by 3, right? What else has happened? Well, yeah, before that. What else happens because it's a negative 3? It is reflected. So, whereas before, remember that normally it's an asymptote, and then y equals the negative number, right? This time, because it's been reflected, it's going to be the positive number, and because we've stretched it, it's going to be positive 3. Then we'll have our 0, then we'll have y equals the negative, and again, it's been stretched by 3, so 3, and then our asymptote. Okay, and then yes, we have a b value, so b is equal to 3, which means that our period equals, sorry, b is 2. Our period is equal to pi over 2 this time. Yeah, okay with how I got that. But same thing as we did last time, okay? I'm not shifting it left and right, so I still want to be centered around 0. So if the full distance of asymptote to asymptote has to be pi over 2, 0 has to be in the middle, how much has to be on either side? If half of it has to be on each side, what is half of pi over 2? Pi over 4, which means I'm going to go a negative pi over 4, and then a positive pi over 4. Which technically means that my y values are going to be at negative pi over 8 and positive pi over 8, but we're not as quite concerned. So this time, because we've been squashed so much, I'm just going to go by pi's over 4. And again, our setup is the same. Just looking at asymptotes. Halfway in between, we're at a 0, okay? But like we said, this time instead of being like down on the left, we're going to be up. It's going to be a 3. And then we're down on the right, and it's going to be a negative 3. So we're just going to make a nice little curve. Yay! What questions do we have about tangent? Like I said, one of the biggest things is going to be able to identify where those asymptotes are. Okay, so knowing where that is, and then the same way of being able to identify the period, being able to identify if it's been stretched or compressed or not, so those types of things. Alrighty.